Hello, my name is Agnes Pox and I'm a project assistant at the Institute for Mechanics and Mechatronics at the TU Wien. Today I give you a short overview about the project CONSERVE. But before I go deeper into the project details, I will start with a motivation and some facts related to this project. Well, it's not news that the majority of the world population plans to live in urban areas. Over 68% see themselves living in cities by 2050. Well, reasons might vary, but the consequences are clear. With more people living in cities, also the amount on deliveries into the cities will increase. Most of the goods reach their final destination with temperature-controlled cars that are smaller. Unfortunately, over 700 million tons of food get wasted because of unreliable temperature control. Also, these trucks pollute the air inside the cities. 13 million tons of CO2 emissions are caused by those trucks. Next to the air pollution, the noise also affects the people that live into the cities. Around 30% caused by those trucks. But not only the environment faces the negative side effects by those trucks. Also, nearly 40% of the transport industries sees the temperature-controlled trucks as biggest risk in the supply chain. Well, a big part of the automotive industry sees as only solution to go fully electric. But how to maximize the range of the vehicle while keeping the driver with the maximum availability of the cooling function? Well, a greener future comes with a few challenges. Especially the battery is the crucial part of the whole system. It limited the driving range and also the availability for recharging is limited. A fully electrified car doesn't only supply the powertrain, it also supplies the cooling unit. Same as all comfort units for the driver, as the heating, ventilation or air conditioning. Keeping the goods at the correct temperature can also be crucial. If you think, for example, on the transport of the COVID vaccination, some vaccines would be wasted if the cold chain would break. So, which concept can integrate the surroundings, the disturbances with all the forecast while minimizing the energy cost to maximize the range? Also keeping all the technical and thermal constraints. Well, all these qualities speak for the model predictive controller. To find an optimal operating strategy, for a fully electric last mile transport, a group of research partners were brought together. This group includes, next to the Institute of Mechanics and Mechatronics, the IFA, an Institute for Powertrains and Automotive Technologies. Also the INIESTA, an Institute for Advanced Energy Systems and Transport Applications. And the industrial partners Product Blocks, Mechatronics and Voltea. The project is also founded by the FFG, an Austrian research promotion agency. The project team at the Mechanics and Mechatronics Institute consists of Professor Martin Kotzek and myself. Together with the other partners, we work on particular topics to bring the first prototype of such fully electrified smart cooling truck on the streets of Vienna. To achieve this, a concept of 4 different main tasks was created. One is the monitoring of the cargo space with sensors and thermal cameras. The other part is about preconditioning strategies, which means the influence of pre-cooling of the cargo or cargo space. Also, the design of the insulation is a huge part of this work package. Another task is to develop a model of the cooling system for state estimation. Also, the fault identification and isolation shall be investigated here. And the last task is to find a predictive optimal control concept. This task is the main subject of our institute, to find a control strategy that allows a predictive and energy optimal control of the cooling system. The CONSERVE project proposed a smart cooling truck with a longer driving range as a regular car. I want to show in short what a model predictive controller is and what it consists about in this project explicit. So first of all, we have the thermal influences to our system and controller. Most significant disturbance is the door opening. Just in a few seconds, a door opening brings a huge amount into heat into the cargo space. We also can feed the MPC with known data to predict the delivery schedule, therefore our door openings, or the weather forecast. Furthermore, for an accurate model description, we can use the knowledge and the description of all surroundings. Therefore, we can build a dynamic model of our overall system. Including all those informations, we find an optimal solution while also keeping the technical and thermal constraints. Behind this simple illustrated graphic, we find a constrained quadratic optimization problem. A classic linear MPC can be formulated. The model has to be discretized using a zero hold and is formulated as state space model. The model is also augmented to provide an offset-free control. By solving such optimization problem, the MPC delivers the optimal cooling for the cargo. To show some current results of this project, I want to refer to the two publications at IEEE. The one is the holistic simulation of an all-electric refrigerated delivery vehicle, and the other one is the model predictive temperature control for a food transporter with door openings. As shown in the diagrams, a model for the main disturbance, the door openings on the right side, was developed, and different MPC strategies were investigated on the left side. Based on weighting parameters of the MPC, a pre-cooling effect could be shown, and also a comparison to a regular PE controller was shown. The MPC shows the more flexible framework and also will be further enhanced in future works. This project is still ongoing till end of this year, 2021. We could already achieve an optimal operating strategy for a smart cooling truck and maximize the range. The prototype is already driving on Vienna streets with zero emissions. In the next weeks and months, the prototype will also be tested on the test bench, and the results will be included into the operating strategies for the smart cooling truck. The MPC will be verified on the test bench, and the state estimation on the system will be also tested on the prototype. Thank you for watching this video, and if you have any further questions related to this project, please contact us anytime.